right, thank you everyone for coming out today. It's been an excellent turnout, definitely great presentation, great panels. Today we have another very stacked panel discussing the proof markets, centralized versus decentralized. As we know, ZK proofs are essentially a trustless way to verify computation, as well as make data essentially not available, but you can still prove that it's correct. So, with the perspective of proof markets, where we have many various different types of services, ones that focus on essentially a targeted structure, but also provide a way for many other people to process proofs. So today I want to start us off with introductions, just what you're doing with your project and how this involves ZK proofs.
So I'm Roshan and I'm a researcher at Marlin. So at Marlin we're basically building a proof market that lets projects outsource ZK proof computation to us. We have like a network of operators who have like optimized hardware for ZK proof generation that lets them hopefully do it like better, cheaper and faster than you can probably do it on your own. So something fairly unique that we do is like support for private inputs, and that lets you delegate proof generation from like end user applications without like compromising on the confidentiality.
Hey everyone, my name is Nick. I'm one of the co-founders of Sindri. We're building an enterprise-grade ZK proving solution for ZK rollups, for ZK apps, and we remove the cost, complexity, the time to deploy and maintain ZK infrastructure. And as it pertains to this panel, we're not building a decentralized proving network. We're solely focused on nailing the fundamentals of ZK proof generation.
Hey, I am Omer Sadika, co-founder at dWallet Network. We are building a new infrastructure, new network that enables builders to build zero-trust protocols. The idea of a zero-trust protocol is a protocol where you can operate across different chains and keep the zero-trust assumptions that you have in a blockchain. That means that it's not possible to steal the user assets without the user consent. So you get the same level of security that you have in other blockchains. To do that, we invented a new type of MPC, we call it 2PC MPC, where the user is participating together with the blockchain in the MPC, generating the signatures. And as part of that, we created a new type of specific ZK proofs to prove to the user side that there is no way that the network is malicious and trying to steal their user share. That means the access to the assets. And also we created as part of that a new type of proof aggregation. So for the user it will be just one proof that the user needs to validate and not to go through the whole network and verify each proof separately.
Hello, I'm Yen. I came from Pi Squared. I'm a developer. So while my introduction, I might have like coming up with technical terms, but if you don't understand, say, please come to us and or raise a question here. We have a technical team sitting there. But basically, Pi Squared stands for proof of proof, where Pi is a proof. So proof of proof is that essentially we generate ZK proof on top of mathematical proofs. And using that way, we can bring universal verified computing into this world. In terms of universality, it is brought by mathematical logics because you can define any programming languages or any kinds of computation by this mathematical logic, and you can prove your correctness. And once you can bridge that gap, and then you can automatically have all the ZK knowledge enabled for you. And besides, in terms of the backend of proof generation, we are able to work with any backends, either it's like RIG0 or any other backends. People sitting here, we wanted to make use of the existing knowledge, existing techniques, and we wanted to build the fastest zero-knowledge proof. And with mathematical proof, there is something better, is that you can, when you have a program converted to mathematical proof, you can actually have focus on your business logic, and in terms of building your ZK-proof knowledge of what you really want to do, instead of you have to like converting all the low-level computer architecture stuff, execution details to zero knowledge proof. In terms of that you can have an extra layer of optimization in terms of input to your ZK VMs. Thank you.
Hi everyone, my name is Norbert. I work for Gevulot and I'm doing protocol research. We are building a decentralized ZK cloud, basically an internet-scale compute network exclusively optimized for proving and verification. And basically one of our unique features is that we are building an interface and making it possible for anyone to deploy any proof system or prover program on Gevulot and supply basically or procure basically cheap proving. We are a good fit to serve direct needs for ZKPs, but also since we are focusing on the supply side, providing compute supply to any applications, we could actually easily fit in other prover networks or proof marketplaces, other proving services to serve them with decentralized compute. Yeah.
Awesome. So it sounds like everyone's doing things related to proof generation. I guess this ties into the next question of projects right now are looking at running their own prover services, looking to build out their own infrastructure. I guess in your opinions, should they still do that? Should they build it in-house, or should they outsource it to more specialized firms? What are your thoughts?
So I think it probably depends on the stage that you guys are in. In a way, I would draw parallels to like how development works for like normal applications, right? You probably start developing by running infrastructure yourself. You probably run your own servers, maybe run development servers and stuff like that. But at some point when you're looking to go into production, you kind of have to crystallize stuff around your application, right? You can't be running infrastructure yourself at that point. You kind of have to look for like partners who can like take that forward, make it scale and all of that. So yeah, it's probably fine enough to like start with running your own stuff. There's a lot of advantages in terms of it being in your control, which means like you get to change it tomorrow if you don't like it. You really need to like freeze a lot of stuff. But yeah, as time goes on, you should be looking at outsourcing to a proof market, a proven network or something like that. Yeah.
Yeah, I think teams generally underestimate the complexity involved with deploying and maintaining ZK infrastructure. And so I think it's the same build versus buy decision you would make when deploying any other kind of enterprise service. And modern tech companies, they have consumed 15 to 20 SaaS services, and I think the future of ZK will play out in a similar way.
I believe that it really depends on the use case, and that also connected to the technology, the scheme that you're using for ZK, because we don't have just one scheme, we have different schemes for different use cases. You have also general purpose and you have specific algorithms or protocols. So it really depends. For example, in our case, because we created the specific ZK proofs for the MPC for proving that the parties are not malicious, for that you can't really use existing solutions. So you need to build something that is relevant for that. But whenever you think about a more general purpose and something that many others are using, then it makes sense to outsource that.
I mean, before pi squared, before our universal approach, if you have, I know lots of people like you wanted to issue your own chain, even design your own smart contract language, your own virtual machine. And if you wanted that virtual machine to have a ZK capability, you might need to build it all by yourself, right? But in terms of like pi squared, you might be simply need to convert or translate your language or your VM into our mathematical logic, and you automatically have the infrastructure ready. And you can even choose which backend you want to work with, because we bridge the difference there. And yeah, that's pretty much what I want to say. And but instead of like if you come up with a new set of instruction set, then you might need a new ZK VM. That's a different problem then. Thank you.
Yeah, from my side, I think that totally agree with what you guys said. Maybe one last thing. It depends what kind of characteristics those proving services have. So, for example, most of the rollups currently, or the L2s out there, are doing proving like in a centralized fashion, as well as sequencing, but that's a different story. So when they are looking at outsourcing proving, or rather building their own prover networks, or like enshrined prover networks, I think there has been quite a bit of debate last year around this time whether the L2s should build their own or not. I think at the end of the day, they would be looking for those types of characteristics like liveness guarantees, execution guarantees, censorship resistance that they would reach building their own stuff. And if they can find it somewhere else, a decentralized permissionless solution with all those guarantees, I feel that over time, as things mature, they will be more and more, that we will see more and more such decentralization and outsourcing from the big players as well.
I just want to add a bit more. I don't want to like overselling our product, but I just wanted to expand a bit more. So when I say that when you can translate your language into our mathematical language, it actually won't take too much time. And from our experience, that if you have a general purpose program language, it might take 3 months just to convert it into a mathematical language specification. And besides that, you might also want to know, is this translation process correct? Or can I test it? That's the problem, right? And then in terms of like this translation, yes, you can test it. We do like compliance testing. Essentially, our logic is executable. Your definition is executable. You can run it parallelly with your existing compiler just to test whether your translation is correct, or your program will, after translation, runs correctly. So, and besides, we are based on formal methods. You might be already heard from the debug people. Formal methods does proof. Everything you do is mathematically proved. You have a very minimal trust set of like matching logic is the formalism we based on. It only has 13 rules. So it's very small set. I wouldn't say that we assure you that it's completely correct, but when you have a minimum trusting set, you might have a much bigger confidence on this approach. Sorry.
So that ties in, you mentioned something about liveness. So when thinking about these production-ready ZK proof generation services, what are some thoughts to generating larger jobs, and how do you guarantee that those larger jobs would be executed correctly, depending on each structure? So how can we guarantee that the execution of the proof would reliably be posted, essentially?
I mean, I can talk about Gevulot's architecture a little bit, but don't want to go into too many details. Don't want to bore the audience either. But from our side, we are building in economic guarantees. Obviously, our prover nodes will be staked. In case they don't deliver, there will be disincentives for that. Also, we are building in positive motivators, meaning the faster they deliver, the more they earn. That's another important thing, a little unrelated though. But also, we are building in fallback mechanisms in case one of the provers, like the prover doesn't deliver the job. Also adding the option for the user, the proof requester, to define the amount of redundancy they want initially. So in case they don't even want to wait for the fallback mechanism to kick in case of a prover failure, and then wait for the fallback prover to generate the job or to generate the proof, they can even add more redundancy. And in general, maybe as an underlying principle, we use randomness to allocate jobs, which is quite a neutral, like one of the most neutral ways to allocate them. And in a decentralized network, that's how we also try to minimize such failures or malicious acting.
So I'll skip this question. It's more for the backend people.
Yeah, so for Calypso, I think it's pretty much similar. The fundamental mechanism that we rely on is economic security. But as you mentioned, it's quite important to mention that it's a pretty broad question of like mechanism design. right? Like how do you want your protocol to look like? How do you want it to like recover from failure? What should the cost of a failure be? What should the cost of like a recovery be and stuff like that? And it also honestly depends on the applications as to what they want to pick for like each of these aspects, right? So from the perspective of a protocol, if you ask me, it's probably important to just be like flexible and sort of like leave it to the applications to pick and choose based on like what sort of guarantees they want.
So should the protocol develop those fallback mechanisms, or should the prover service, the prover network, have those built-in guarantees, I guess?
Yeah, they should. It should sort of be like, I don't know, sort of like a choose your own adventure kind of thing. Essentially, you provide components out of the box that are like integrated into your protocol, right? And the applications pretty much like get to choose, hey, okay, maybe I want to proofread for this, or maybe I want to do an auction for this, right? And it's still currently under research because we essentially started out building a proof market, but I think it was during one of the calls like the Aztec growing ecosystem, where the importance of like having your proof market sort of be like proof agnostic became like really clear. So yeah, it's pretty much still in research right now.
Yeah, I think in Web3, reliability matters a lot more than it might in other industries. So our approach is to aggregate compute across multiple cloud providers and try to provide SLA level guarantees. But having those redundancies is super important.
Perfect. Awesome. So in terms of generating circuits, so we've seen domain-specific languages like Circom, like Cairo, Noir. These are all created basically to create highly optimized circuits. And there are now ZK VMs that are essentially running the whole VM as a circuit. Do you see a trend in specialized hardware for ZK proof generation, or a more generalized approach where you can just run it from a graphics card and it doesn't really matter what kind of device. It's
Special hardware is of course really important. We've kind of not really had that until like very recently because the ZK space has been in a state of flux, right? The tape-out process for an asset probably takes like, I don't know, 2 to 3 years from like design to when you actually get a chip in your hand. And when the space is changing like so rapidly with like new optimizations or like new proof systems and stuff like coming out pretty much every month, it's really hard for things to like settle down and like actually make an ASIC out of it, right? But there were talk by Justin Drake like during, I think it was like ZK Summit in Athens, where he basically brought a lot of samples of like ZK ASICs that actually exist today, right? So companies like, and there's also a lot of variety in terms of like what companies are going for. For example, people like Axial are basically making chips that accelerate specific parts of a ZK proof, for example, entities and MSNs and all that. People like CISIC are sort of trying to put their entire proving process on a chip, right? And actually, I forget the name, but there was an interesting project which is essentially trying to build a GPU where like fields are the native type instead of like integers, right? So there's a wide variety of like approaches people are taking in terms of like bringing hardware to the ZK space, and yeah, it's of course really important. It's way more efficient and like way more faster if you have like you know, specialized hardware that's used to like generate ZK proofs.
One quick thing, I think 2 days ago Jordi mentioned it in the ZK Hack Meetup, in his talk at ZK Hack Meetup, that they actually just partnered with Fabric Cryptography, who
Fabric was the one who's making the
chip, who are basically building some kind of generic VPU chip that is now basically going to like more general purpose specialized hardware that is going to support Proki 2 and Proki 3. So it's great to see that variety, and also that these providers are creative enough to figure out ways to build basically general purpose specialized hardware.
I really love this idea that hardware is going to participate. Although I know nothing about hardware, but I know pretty well about software. I know software cannot solve all the problems. Eventually, you will need dedicated hardware designed if you want to reach the best performance. Yeah, I love to see that emerging. Thank you.
So in our case, we have a specific type of proofs that we created, and they're very fast. But still, we looked into it from the perspective of adding more transactions per second, or signatures per second in our case. So we wanted to get to even, not just thousands of transactions, to get to tens of thousands and even more. And what we have seen is that today, even with GPUs, without getting to ASICs and specific hardware, the results are amazing compared to just running it locally on CPUs. And it seems like if you think about ASICs, of course it will improve that. But the question is how much and if it's worth it, right? Because ASICs is super expensive, you have to spend a lot of time, you have to produce ASICs, it's not simple like GPUs. So I think time will tell. It's not a question that we can just answer. We'll see if GPUs is enough, if not, and if we need something more than that, and if it's worth to build ASICs specifically for those tasks.
We took a very hardware-oriented approach initially, and I think what we found is there were diminishing returns to further hardware-oriented optimization. So I think the value prop of building specialized hardware shifted from one around performance to one more around efficiency, and I would totally agree with what others have said. The proving systems are such a moving target. You could invest tens of millions of dollars in building specialized hardware, and then a new proving system might come out with totally different algorithmic bottlenecks, and then your investment would be wasted. So that's why I think there's been everyone's kind of built around GPUs.
Yeah, that's the downside of being on cutting edge technology is that you're sort of on the race with what is the new technology, and if you invest a lot into what currently works, maybe someone comes up with a better solution that proves, kind of like how Plonky 2 sort of changed the proving game. That definitely we will see more and more of that, I think, in the future. So I guess talking about different proof systems, what would you say would be the main challenges for integrating different types of ZK proof generation services? So you essentially you can focus on different types of the mechanisms within the proven network. So how do you keep things open for integration? And is there difficulty with creating new proof markets or proof services within your systems?
Right. So I'll probably answer this in two parts. From the perspective of the proof market itself, it's not really that hard, because at the end of the day, what you're looking to do is basically define some common interfaces that people can program against, right? That's pretty much a solved problem. You just create an API that people can use. You solve define interfaces, right? Documentation, that's a done deal, right? The biggest challenge for us has been the fact that pretty much, even though you already have an interface, right, you still have to adapt every ZK system and every proven system into your market to actually conform to that interface, right? And the problem over there is basically every system today pretty much has a different tooling, different stack, different language. To the point where, let's say I wanted to GPU accelerate something, that there's pretty much a whole variety of libraries that people are using, HoZK, Gevulot, this and that, right? So even though it's not that hard to standardize the interface, it's really hard to actually make the proving systems conform to that interface. There's a lot of engineering effort and work that needs to go into it to make sure it's actually ready for the proof market. Yeah.
From our side, I think, I also understood your question a little bit, how to integrate different mechanisms, let's say different types of, I don't know, auction-based, order book-based, randomness-based, such mechanisms. And I think a very interesting tool maybe, or even we could call it layer or relay, would be something that the Aztec team already started talking about, which they call proof boost or prover boost, if I'm not mistaken. So some layer that could actually facilitate easy communication and sourcing of proofs between proof providers and proof requesters. And then if we think about it in a universalized way, in a broad way, it could actually even abstract away most of the complexity for proof requesters, even like large L2s, to say, okay, I plug into this layer where any prover market, proof network could connect, that all of these prover markets or proof networks could connect to. And then I can select whichever method I want. I trust auctions to give me the cheapest price. I'll go with that, and that will channel my request to solutions that are providing that, etc., etc. So I think it's quite complex to build. It's still quite missing, even though I know there are some initiatives already running, but it's something that could be super useful to abstract away the complexity from resourcing or sourcing proofs.
I can add a little bit more. Actually, we are in our project in our company. We already started to try to integrate the backends. And the first thing you need to do is that you need to translate our mathematical language into the input formats the ZKVM supports, and that's a bit of work. And then I would think that in case if we going a little bit upper, where an application builder or ecosystem builder, if they wanted to do this, if they wanted to have a ZK capability built for their ecosystem, it will be even harder, because we are program language experts. That considerably is less difficult for us. But if for the application builders, that's very much difficult. And besides, it's not only that you need to handle one ZKVM backend. You might, if you wanted to have bigger or better choices, you might want to handle multiple backends. That will be eating up lots of your time and effort in the team. That's why that's one thing. And in terms of us, that we wanted to really promote our mathematical logic frameworks that eventually you don't really have to know about the ZKVM inputs or configurations, etc. You can just know what your language does and what your VM does, and then that's all. You can have your ZKVM. And besides, we going down a little bit where we wanted to make those backends running. And although I'm not directly involved with that team, but I know that there are difficulties because there are so many tricks and so many configurations, which algorithm you wanted to go and which optimization you want to choose. And those kind of thing is if we do not set up correctly, our performance or profiling result might not be beneficial for the ZKVMs. And now that's kind of one of the major purpose we are here. We talk to the ZK backend team to get the tech support that how we're going to use the ZK backend to get the optimal result. And we are progressing on that, and eventually we will share the result to the public.
Thank you for outlining the overall different types of challenges for protocol design. Definitely when you're thinking about it from high level, from the mathematical point, and then you need to think about it from the game theoretical, and also the how do I integrate this and make it available for everyone to apply for many different types of use cases. So this also goes into another question. So if we're all familiar with Moore's law, where I guess it's the exponential rate of essentially the power of computation is increasing every year exponentially. And then the cost of computation is decreasing, efficiency of proof generation. Do you think that within the near future that dedicated prover services, prover networks would be relevant, and then how would is there a case where I don't need to use the services that require these things.
Yeah, maybe I can provide you. Honestly, the ZK endgame and like the future that we are looking at and we are working towards is like ZK everything, and it's gonna go. What we expect is that it's gonna go. The demand for ZKPs is going to grow exponentially, and it's going to go way beyond just blockchain. So I do think that while efficiency increases, compute cost decreases, etc., the increase in demand will bring, for a considerable amount of time, I think will bring sufficient job to these prover markets or prover networks out there. And that's like if you just imagine now you need to trust Amazon when you rent a server, and what if they were attaching a ZKP to the computation that they have done for you? That's just one thing. Or like I don't know, attach a ZKP to any media piece that was human created, so that you can differentiate between AI created content or whether the content has been modified, etc. Or just I think it's been also I think Daniel was talking about it in one of the previous panels, like banks between each other attaching ZKPs to their intra-bank transactions, or like to any bank transfer. Then a lot of the trust assumptions, a lot of the audit costs, the security costs, the hedging, the risks, etc., etc. It just goes away. It's going to be super useful as a tech for, I would say, for any interaction that we have, basically, or any content or any computation, etc., etc. So that's just my thought, and that's the vision or the future that we think is coming. So I think there will be space for these services even 10 years from now.
Yeah. I have a different perspective about it. I think if you look on Web 2, because I think it's a good way to look on history and see how you can apply that to Web 3. We started with innovation, and then SSL and HTTPS became the standard. In the beginning it was super expensive, right? Then it became cheap, and now you have it everywhere. Right? And then people, hey, doesn't work. Can you hear me?
We just lost that.
Oh,
Can you hear me? Okay, so let's, okay, I'm back. So then it became very cheap. Everybody felt like, okay, we can do everything on computer and CPUs, and then AI came, and now we see, okay, we need a lot of computation, right? So I think it's really about the use cases. So I think what will happen, of course, if we don't really know, in that case, I believe we'll see a shift in use cases, and probably those use cases will try to be more heavily computing use cases, right? Where you can't run them anymore on your laptop, right? So maybe things that you couldn't run, now you can run on the laptop, or the device or the smartphone. But then builders will start to go to the next use cases where you need more than just running it locally.
I wanted to add something, although not from a company perspective, from my personal perspective. I wanted that someday this computation power cost is much smaller and it can run on a mobile phone. So which means I can run ZKP on my mobile phone, then I don't have to tell anybody what I'm doing. I don't want to exchange my data as well. So that would be good, but everybody's comparing Web 3 to Web 2, and eventually, small computations can run on mobile, that's what I want, but eventually there are bigger computations, larger tasks, you definitely need a proof service infrastructures externally. That's just like nowadays you can do a lot of things, even training a model in your mobile phone, but you still need the cloud infrastructure to do the computing for the big, larger tasks.
Yeah, I would agree. I mean, the demand is pretty much a moving target, right? And like ZK is far behind traditional computing in terms of actually being saturated, and computing is still growing at an insane pace, right? Like there's a famous quote from like Bill Gates, right, about just needing like 500 KB of RAM or something like that, right? Back when like Microsoft got started, and I mean, look where we are today, right? So Yeah, it's always a moving target. Sure, stuff that you do today is probably gonna be cheaper in the future. I mean, I would hope that it's cheaper in the future, right? But that just leads to people wanting to do more with that, like phones and computers and like ZK proofs. So yeah.
I think you can draw a parallel to the last few decades, and machine learning and hardware has gotten better and better. But and as we've gotten more compute power, that's expanded the solution space of what's possible, and now you can build large language models. And so I tend to agree with Norbert and the vision of the ZK endgame, where more and more types of use cases and applications are possible to be built.
Awesome. I'm glad everyone has a positive outlook in terms of the both consumer demand as well as the necessity for proving services in the future. Everyone needs computational power, and machine learning has been probably the easiest case for that. We do have, I guess, a bit short on time. What would you like to tell the audience? Anything that your project is working on? Any type of developments? Anything to do? I guess like we'll do it like a minute each.
Yeah. So something that we're really excited about, and as Norbert alluded to, is the research space around designing like a mechanism agnostic sort of like proof of market or like proof of network, right? Where we know that different protocols have different requirements in terms of like the mechanism design and stuff that they want. So you really want your proof market to be able to cater to all of those use cases, right? So a lot of like really interesting research is underway, like along with the HoZK team and all those guys, to basically figure out like how do you actually do this for like a proof market, like proof outsourcing, like proof of boost and stuff, for example. So yeah, I'm really excited to see like how that works out in the future.
I'm excited about the day when deploying ZK rollups becomes as easy as deploying optimistic rollups. So we're working with layer 2 teams, we're working with RAS providers, and we're supporting the prover component of these different ZK EVM prover implementations. And I think that will be coming soon, so excited for that.
I think first of all, what I want to say that I think maybe people don't know or don't get or understand is about MPC, and our focus is a lot about MPC. But in MPC, especially when it comes to signatures, ZK is super important, because you need to make sure that the parties are not malicious, and you use ZK to prove what each one of them have done, and if it's correctly, if it's based on the protocol and the way that they should do it. And we're working a lot. We have on the team over a dozen cryptographers. One of our main focuses is on ZK. Because of that, right, we try to reduce and also to improve what we have. We have some research around that. We have a paper that we're going to publish later that is also connected to range proof, some breakthroughs that we had. So in general, just to get that, when you think about ZK or you think about FHE or MPC, they sound to you like they are not connected to each other, but it's all connected, like cryptography is cryptography, and it's more than that. And if you follow us, you'll hear more about what we publish and the new papers and the improvements that we're doing.
For our company, I wanted to talk about two aspects. The first one is I already talked about a lot about the universality, that not only the application builder has minimal effort to boost up the ZK capability in your ecosystem, but also that we can have once we integrate the ZK backend, the ZK backend, ZK VMs can easily reach out to different ecosystems with different programming languages and VMs. That would be like a bridge between the top level consumers and the proof service providers at the bottom. So that's the first aspect. And the second aspect, what we are trying to look is that we really wanted to find that what will be the killing scenario that ZK technology will be used. And specifically with our program language background strength, we think that with ZK proof, existing, especially for heterogeneous blockchains, if you want to cross-chain, it's really a headache. You are forced to trust the third-party validators or some other kind of things, even with ZK enabled. And in that case, we think the fundamental problem is that the different blockchains, they speak different languages, right? And they have different consensus mechanisms. And the pain point is that they can't verify each other because I don't understand what you're doing, right? So, but in terms of that, we were saying that if we are able to mask away this difference, which means if we're able to let both heterogeneous blockchains to speak the same language, having the same formats of exchanging messages, like a claim that with your states changes with your proofs, and then maybe the chains can verify each other without relying on third party. So that's the problem we are looking to, although we don't have a mature solution yet, but that will be very interesting. And if any of you have an idea, that we will love to explore.
Yeah, I think we are out of time. I'll be quick. No worries, I'll be quick. So, to learn more about Gevulot, we have docs.gevulot.com where you can see and you can read a lot more. We have a DevNet running with the entire proving pipeline, which means you can deploy an improver program as an on-chain program on Gevulot and generate proofs for free. We are extending that and launching a production-grade, scalable to hundreds or even thousands of nodes, scalable mainnet level network in a couple of weeks' time. We would be happy to serve as many use cases as we can, but I guess I'm speaking in the name of all of us here, like Sindri, Marlin, and with a common effort, I think we'd be happy to serve the industry with ZKPs.
Awesome, serving together, awesome. Thank you. Give a round of applause for our panelists. Thank you so much.